Hello everyone, my name is Anuj Mehta and this is my submission for ME 185 term project. So this is a simulation of an HEV model in MATLAB and Simulink, which uses a few toolboxes that were, let's say, very difficult to get access to. Okay, so the objective of this project is to simulate a few output parameters of an HEV, which in this case is a Toyota Prius, through this rather sophisticated model that can provide tens of other outputs based on the input parameters. I will be measuring the state of charge and the output voltage of the battery as well as the fuel economy of the IC engine. First, let's have a look at the kinds of Simulink blocks that were used to create this model. Starting with the input block, which feeds drive cycle data into the model that we'll be using in the later part of the presentation. The drive cycle data is processed by the control system block, which is a subsystem in itself that looks like this. It has a bunch of logical operating blocks that decide what system to kick in based on the velocity requirement of the vehicle. It also has a battery charge controller that is programmed to switch from motor to generator and vice versa according to the requirements. Moving forward, the control system sends signals to the electric drive system, which looks like this. It has a motor and a generator, as you would expect. It also has a bunch of sensors that send data from the shafts of the motor and the generator to the power split device, which helps in the charging and discharging of the battery. This subsystem also has a DC-DC converter to step up or step down the voltage going to and from the battery, as well as the battery, of course. All this data is finally sent to the vehicle dynamics subsystem, which has two wheels for the rear wheel drive, as well as a vehicle block that outputs the velocity, takes in the wind velocity, mass of the vehicle, frictional coefficients, distances from the center of the gravity, and a few other changeable parameters. All these subsystems alongside an IC engine that is briefly customized to suit this model output quite a few parameters that might be useful to study the behavior of an HEV under certain conditions. There are a few parameters that I was able to find that were specific to the Prius and that were changeable in this model. Moving forward to the simulations, here's the drive cycle input block that will feed the data to this model and hence generate a few graphs and output a couple of values. The first drive cycle replicates a typical ride on a freeway with very minor velocity changes. Here's the fuel economy block after 600 seconds of simulation, which is near to what I found in a research paper linked towards the end in the references section. And the simulation of the velocity, state of charge, and output voltage of the battery with respect to time was as follows. You can see how stable velocity led to the battery being charged again, and a heavy acceleration led to the discharge. In the similar way, we have another drive cycle that imitates an urban driving scenario where brakes are applied quite frequently. Here, as you can observe, the fuel economy is also lower than the other drive cycle because of the fluctuating velocities. The simulation also shows how the battery did not get charged frequently because of the fluctuating velocity requirements of the vehicle. Overall, it was a fun project to work on. Initially, it was a little challenging to understand such a complex model and modify it to kind of replicate a Toyota Prius, but for the sake of the simplicity of this project, I took some liberties in keeping the default values as it is for a few parameters that came with this model. Future scope of this project would be to model various other parallel or series HEVs with custom parameters and simulate their performance based on that. So that's it for the presentation. Finally, I would like to thank the professors as well as everyone who attended the presentation. Thank you.